let's move on to how we really complete the product by taking all these foundation layers, right? A scale out platform, a really performant database layer, and how we layer on top of that rich enterprise data services. And so let's start with, the sort of obvious segments that need security, access controls, snapshots, replication, sort of all the expected enterprise features. Like, of course, the banking industry wants this. High-scale SaaS environments are actually quite heavily either regulated or have to put a high degree of security controls in for their customers. And the healthcare industry is of course heavily regulated, has extreme privacy and data protection concerns. So of course, to serve these markets, we have to offer rich enterprise data services and features. But what about the chip designers? What about the high-scale software development teams? What about the gaming studios? Do they need all these enterprise features, or should we be building a system that's just fast and big? And I want to use a particular industry example to really make the case that these enterprise features are universal. So consider the challenge of operating a top 10 global semiconductor firm. And if we were using this example a year ago, it might be a little bit more obscure. But if you've tried to buy a computer or much less a GPU in the last, 6 months, there's a worldwide shortage. Semiconductors, it's affecting automobile production. This is a strategic industry for every industrialized country at this point. And the challenge that the companies that work on these semiconductors that are so vital, these are massive projects. So a top 10 semiconductor firm has easily tens of thousands of engineers. What do? They write code. They write code for building the hardware, designing the hardware. They write code for all the software, all the operating systems and firmware and system software that runs on that vendor's hardware. And they run tons and tons of simulations. So clearly they're a modern, unstructured data, very high scale, kind of industry segment. But what happens when there's a runaway job? These deployments have tens of thousands of compute cores in simulation grids. What do we as an infrastructure provider do if there's a runaway job? 30,000 people, there's potential for human error. Networks are going to fail. Ransomware is a concern everywhere. So even for the highest of tech, most HPC type environments, we found a strong need for enterprise features. And it's difficult to sort of summarize everything in one easy way. So this is quite the eye chart of everything much of what we've been building over the last really 5 years to extend this core platform with rich support for different protocols, everything from user quotas, group quotas, all kinds of authentication systems, access control lists, all of the object capabilities. We're not done. We've still got, there's always the next frontier of this. We've got a lot in the product already. And I want to spend a bit of time really narrowing in, if you will, on one piece of that, which is what we've done in the replication space. And so for a little over a year now, we've had really rich file and object replication in the platform. And it's gone extremely well with customers. This was a much requested feature. So I want to do a little bit of a technical deep dive into how we built file replication in particular. And so let's look at the basic architectural model. And our goal here is to create a very simple, flexible object model that makes it easy for customers to reason about how to set up replication connections. And so the basic walkthrough is I have two systems, two FlashBlades that can be in a data center. They can be separated over a WAN, and you create a secure connection between those two arrays. So once that connection is established, we then, for any file system we want to use as a source, we set up a replica link to that target. We can apply then policies. We can compose policies so that you can now have different snapshot schedules and retention policies on the target. They can go in different directions. We have one-click disaster recovery workflows where you can fail over and fail back. We have all of this exposed through REST APIs, so you can build automation, Ansible plugins, Terraform providers, lots and lots of different ways in which customers can orchestrate the mechanisms that exist in the system. But it's really designed to be, frankly, quite simple. And one of the challenges that we were hearing from customers was that in some of their existing deployments from very mainstream, high scale file offerings, they were having trouble with the replication capabilities. There were issues creeping in as data volume scaled. And, frankly, replication, it shouldn't be exciting. Right? If your replication is exciting, I'm sorry, it should be just this simple. Right? Take a snapshot, move it to another side, protect your data. So what's the big deal, right? If I have this file data sitting in some system, I'm going to take a snapshot and I'm going to ship it over to another side. Why is this so hard? Well, it's really the challenges that come from modern data. And modern unstructured data, as we've said, right, it scales to billions of files and directories, petabytes of data. All these servers, all these cores, they can drive extremely high change rates. And of course, you have to deal with potential wide area network disruptions, pauses. And so that's always been there. But modern data is really about hitting this scale. And that has posed a challenge for some of the incumbents in this space. And so let's look a little bit at how we've overcome some of these challenges, starting with the namespace scale. And it really comes back to that core database component of our architecture. And the fact that we built this really rich, robust database platform internally allowed us to have native change tracking, right? Understanding what files have been updated is, I wouldn't say it's trivial, it's a lot of engineering work, but change tracking is a pretty well understood technology, and we'll never have to crawl a file system. And change tracking as it existed in existing enterprise file systems, but the way we built it with this underlying parallel database has enabled us to keep up with very, very high scale metadata systems. The second problem of how do you deal with really high change rates? So all these servers, all these cores that are writing new data, well, we've done what hopefully everybody would expect, which is we have efficient incremental forever snapshots that get shipped over from the source to the target once we've gotten through that first baseline. But really, it's that distributed, sharded architecture under the covers that allows us to fully parallelize all the replication mechanisms under the covers. So we're using all the cores and all the blades in the system to serve front-end traffic, but also to help track and ship changes over to that target and apply those changes at the target. And that's really helped us keep up with the kinds of high performance use cases that customers are driving. We've seen in production now with customers that were replicating data, they're hitting over 10 gigabytes a second on their replica link. Now, obviously, you got to have a WAN infrastructure that can support that, or a network if you're doing an in data center, replica link. But the sort of proof point of this parallel architecture has really played out well for us in practice as we tackle some of these, performance demanding workloads that still need enterprise, data protection features.
Just a real quick question on that too. What's the granularity of your replication? Is it per file, per block, per object?
Yeah, great question. So it's sub file or sub object, and so we really look at it at the database level. This is internal. If we're writing a portion of a file, we'll ship just those changes required. And so you could think of it in that sense as per block, although it's not exactly a block. It's variable blocks, but it's definitely extent and then metadata changes.
So in that example, let's say an example of, say you're replicating the underlying file for a virtual machine. From a replication perspective, like what parts would that be replicating of like, say, a large VMDK file?
So it's really, when there's a file system layered on top, like, a VMFS or, something that's sitting on top of our storage system, it's going to be the, what bits of those files, the VMDK files, have changed. And so as VMware really, and the same is true of any other software layer that's in front of us, if it's be it a database or something like a hypervisor, it's laying out, it's responsible for the layout within the set of files that it's representing. And we'll see those as, writes that come to certain extents and we'll ship just those incremental changes. So the last piece of how we really, support high scale replication environments is, you have to deal with, everybody has to deal with WAN disruptions. You cannot assume any part of the network is reliable. And for that, we're taking internal checkpoints of the progress, right? So these are efficient, again, inside of that database system that we have. We can easily track where we were in that progress and handle all manner of different kinds of disruptions, pauses, et cetera, so that we have really efficient restarts when the network is repaired. And so all of these things, come together. And in practice, here's an example, and it's actually at a leading semiconductor company, well-known organization, very large scale in terms of number of engineers. This is what one of their systems looks like on a typical Tuesday. You've got this is a 29 blade system as they configured it. You can see on the left, they've got about 3/4 of a petabyte of file data. They are keeping and retaining a number of snapshots across this system that they then replicate to another target. And so there's actually a pretty mixed workload here, though. If you go in and as we go in and look at internally what they're doing, they've got about 145 total file systems configured. 121 of them have snapshots enabled, right? So some of those file systems are scratch use cases that are driven by simulations, is pretty typical in this industry. And about half of the file systems with snapshots are replicating those. And so they have different types of data, different workflows in their overall environment. They've got, these sort of layers of different protection, and they're driving, a pretty good change rate. This is averaging a couple of gigabytes a second on this system. And this is just actually one of 5 that they have deployed globally at just this one customer. And so we've been working with customers in the semiconductor space and pretty much every other major enterprise industry vertical. And the details will vary about what their workflow is like, but the consistent theme that we heard is, from the beginning of deploying FlashBlade back in 2016 was, okay, we love the performance, we're solving real pain points for that customer. They need enterprise features to be able to run production data. And as we've scaled our feature set and capabilities, we've really been able to do that without sacrificing any of the performance. And this is just one instance of that. So hopefully you've seen, right? We really had 3 big bets that we made in designing the product, and they've all come together to help deliver for customers a complete platform. So we have this high scale, we were really simplifying what it means to build a scale out storage system. We've built this robust transactional database engine that drives a lot of the performance capability and delivers the performance opportunity of Flash all the way through to applications. And of course, we've surrounded that with robust protocols, enterprise data services, and features that build on all those platform layers. And we're 5 years in. We couldn't be happier with how things are going. We're thrilled to have kind of a front seat view to what customers are doing with a lot of their modern unstructured data. And it's been a real privilege to get to build a product that's helped so many different kinds of organizations in different scales.
So I saw that you've basically got, so you can do snapshots on basically a volume that you're replicating. So are the snapshots retained at the replica site as well?
Yeah, they can be, it's configurable how you retain at the source site and the target site. So all of those snapshots are extremely efficient, in terms of how they're represented. And so you saw in that customer example that I showed, they had quite a bit of space taken up by snapshots. That's because they have a high change rate, right? If there is no change rate, then the amount of data for the snapshot is not so big.
Right. Can you also then, so with those snapshots, can you set the retention policy then on kind of a is it per volume basis where you can say, I wanted to almost think of like an Apple time machine, how it does backup, where you could snapshot volumes at specific times, but then prune, like only keep dailies for a week, weeklies for a month, monthlies for a year kind of thing?
Yep. So I'll use this as a simple cartoon visual, at least. So this policy engine that's represented here allows us to apply and compose policies that define how frequent and how long to retain. And so you can, and it's very common to have hourly, weekly, monthly, and you do trimming, pruning, thinning of those policies to be efficient.
Okay, and then kind of the last question related to that, is there a failback mechanism to go from basically kind of that FlashBlade B back over to FlashBlade A? And then if so, is that a complete transfer of the data back across the wire, or is it looking at kind of doing a snapshot comparison and replicating only that?
So yes, there is a very simple failover, failback, DR mechanism. I'll explain a little bit how that works, but to the second part of your question, yes, it's efficient in that there's a reconciliation and we only need to ship back the incrementals that were accumulated on the target side while there was the flip.
Yep.
The way this works, just to give you a little bit of a sense of the sort of mechanics, when all is healthy in this snapshot-based scheme, the source is considered promoted. So if you go into the UI, we even show, this file system is promoted, meaning it's writable by any connected client on the source side. You can see on the target, you see the file system and it's indicated as demoted, as in it's there, we've got the data. You can actually go in and mount it and have read-only access to the .snapshot directory. And in the event that source side goes away, or you manually, for testing purposes, you can demote the source side, you promote the target side, write new data in, and then you can flip, you just reverse that to flip the direction back. Great.
Yeah. 9 times out of 10 in those DR scenarios, it's not that the building burnt to the ground. It's got somebody got crazy with a backhoe out in front of the building. So good to see it.
You see it all. Yes, Enrico.
I have another question. Sorry. So you have a lot of CPU power in these blades, and you are managing small files, large files, everything. My question is about, why don't you use some of this CPU power to do something more, integrate, some application inside the system? Like there are some object store that now implement, serverless frameworks, or at least they are compatible with AWS SNS or other messaging system, notification system.
Yep.
So why?
Yep. Great question. And look, it's flip to this other visual just as a bit of a backdrop, right? If you take the 10 to 20 year view of our goals to architect a system, right? We've built a really robust platform layer. So we've thought about a lot of those capabilities. It's really a question of, where are customers pulling us? And that's the great privilege we have of having such success in the market is, we're trying to balance, and this is it's classic product management of we've got to adopt the latest media technology, we've got to get bigger, customers want more performance in different dimensions, cloud integration, enterprise features, and the goal is balance across all of these. And so are there things we've architected for that get to what you're asking? Of course. When is just a question of timing.
Just throughout the entire development of the platform, just out of morbid curiosity, what would you say the hardest engineering challenge was to tackle?
That's a really good one. So systems like this run the risk of, and this is not unique to FlashBlade. I think it's true of any other storage system. I've seen it as I've worked in other database, enterprise database internals. It's the combinatorial effects of having lots of things that you do. And so when you have snapshots and when you have replication and when you have NFS and you have SMB and you have object storage and you have on and on and on and on and on, how do they interact? And it takes a lot of work to try to modularize these things as much as possible, because otherwise you end up with a giant ball of mud. And it's a constant, the architect's challenge, and I've seen this in large-scale relational databases, I've seen this in storage systems. That's the biggest, hardest problem I think anybody that's setting out to design something like this, really faces is, can you come up with good, clean abstractions that have good separations of concerns. And that's why, it's a little bit of a detour in how I've described a lot of this, this whole database that we built. Like, why go to that? Why do all of that? It's really to create strong, robust architectural abstractions that allow us to have good, clean separation of concerns so we can scale the feature set and scale the capacity and the performance and all the other things that customers need.